So when dealing with free fall, some things that you need to be aware of. First of all, we need a little formal definition of it. What is it? Right? What is free fall? In the truest sense of the term, it is when only gravity is affecting you. When only gravity is affecting you. Okay, but there's a caveat to that. We live on Earth. Planet Earth has air. Like, you can't live here without air. So the caveat in our stories will always be there, air exists on Earth. For our purposes, we are going to ignore air resistance unless otherwise told. So I want you kind of to conceptualize this. I'm going to zoom out a little bit. I'm going to draw myself a little basketball hoop. Here's my basketball hoop. Ready? There we go. And whatever. And then here's a guy shooting a jump shot, right? Here's the ground. He has a huge leap. Okay. I don't think that's realistic, but whatever. Here he is shooting a basketball. Okay. So what I need you to understand is that when only gravity is affecting you and we're ignoring air resistance, gravity affects you this way. It's a negative gravitational pull. You're going against gravity, so it's slowing you down. And then you're speeding up. You're going with gravity, so it's a positive. So you can, free fall is not just falling towards the earth. It is any movement where earth is affecting you or gravity is affecting you. So in this case, when you jump, moving away from the earth is still free fall. So free fall counts. Moving up and down. Okay, so what is free fall on Earth? Free fall on Earth. What is free fall speed? Gravity is 9.8 meters per second squared. We often will round to 10 meters per second squared. This is one of those things that you must memorize. This is not allowed to go on the back of your thing. You just memorize it. Memorize. Okay, speed of free fall. Now that we know the speed of free fall, the next thing that we have to figure out is like how fast you're falling at any given second. So first we're going to talk about attacks. So if I set up a chart here, so I actually I have a drawing in class where I chart the kid off of Shaman Hall, right? 1, 2, 3, 4 stories, and they fall off of Chaminade Hall. Well, if I do a table time and I do time and a velocity table, at 0 seconds are going 0 meters per second. At 1 second, if we use the easy one, they're going 10 meters per second. If I do 2 seconds, they're going 20 meters per second. 3 seconds, 30 meters per second. 4 seconds, 40 meters per second. 5 seconds, you get the idea. Okay, so what is the equation that goes along with this, you ask? Oh, I'm glad you asked. Velocity is equal to acceleration times time. So this works horizontally. This is like even horizontal. So if you have a sprinter on the track and they're continuously accelerating, then you can solve for their velocity. Okay. Another way you could write this is V is equal to GT. This is vertical. Because why? Gravity is involved. Both of these are legal for you to put on the back of your textbook. You know what? Or in your notebook. I would even allow you to draw that if that helps you out. Okay, so that's how fast. All you have to do is plug in a number and solve for it. And we're going to get into more complicated portions of this next class. Okay, the next thing I want to know is how far. How far am I going? Oh, look, there are all the notes. Look, so chaotic. How far? So if I throw somebody off a bridge, off a cliff, off whatever, and they're falling, and I time it, and I start the timer when I come off the bridge, I start, they go splat, I stop the timer, and I have a time. So I have a time of like 3 seconds. How do I solve for the distance? How do I solve for the distance? Okay, the first thing I want you to do is I'm going to draw you another picture. As this person falls off the cliff, at 0 seconds, they've gone 0 meters per second. At 1 second, way down here, and they're now moving at 10 meters per second squared. Well, they didn't just magically jump to that. They had to accelerate to that point. So at 1.1 second, at a millisecond, they're maybe going 1 meter per second, right? At 0.2 seconds, they're going 2 meters a second. At 0.3 seconds, they're going 3 meters per second. Okay, so they're gradually accelerating to a final speed of VF of 10 meters per second. So I have to figure out the distance here because it is not 10 meters because they're not automatically going 10 meters per second when they jump off that cliff. They're accelerating to that point. Okay, I'll maybe write acceleration here. Okay, we accelerate to that point. There's an equation that goes along with this. The equation here is distance is 1/2 gt squared. That is the distance somebody can fall. Or I mean, you could replace the g with a, and that would be the horizontal movement. But in this case, the distance is 1/2 gt, and this is for vertical falling. Okay, so if I set up that same table as I did before, but this time I do distance, time, and distance, and I go 0, 1 in seconds, so I don't have to write the units, and distance in meters. You write it at the top, you don't have to write it in every time. 2, 3, 4, 5. This is where I lost some people in class. Okay, distance is d, g is gravity, which you will have to memorize, and t is time. For the sake of ease of the math, I will allow you to use 10. Distance we don't know. We know how long it took them to go splat. We're going to do this a couple times. 1/2 times, we'll do 10 for ease, meters per second squared, times 1 squared. Okay? Distance equals 5 meters per second, notice, times 1. The first distance, so this is 0, this is 5. Okay, if I did it again, distance equals 1/2 10 meters per second squared times 2 seconds. Now that would be 5 meters per second times, 4. So now we're at 20 meters. If you did it a third time, distance equals 1/2 10 meters per second squared times 3 seconds squared. 5 times 9. All right, that equals, distance equals 45. The next one would be 80. Next one would be 125. I'm just not doing the math because I'm running out of time here. Okay, this is how you figure out your total distance. So if they fell for 30 seconds, the falling distance was 45 meters, right? Okay, the last thing to talk about is we talked about falling off the Grand Canyon. In class, we Googled time. You might not get an accurate sound effect off of the Grand Canyon because the Grand Canyon at the tallest spot is 1,857 meters. Okay, I can use the same distance equals 1/2 gt squared, and I can plug this number in. 1,857 meters equals 1/2 10 meters per second squared times t squared. Okay, the next step would be 1,857 meters equals 5 meters per second squared times t squared. How do I get rid of this? It's stuck here. Divide both sides by 5 meters per second squared. 5 meters per second squared. Meters cancel. The numbers, it's like 371 point something. I'm just trying to, here, I'll keep writing. Not opposed to that in this case because we've done it a couple of times. 371.4. Yeah, I know you can see the rest of the answers. 371.4 equals t squared. Now we've talked about this. How do you get rid of the square? That cancels it. Root. Your final answer is about 19 point something. No, I think it was 3 equals time. So if I got kicked somebody or I told a story, someone's taking a selfie off the Grand Canyon and they keep stepping back to get a better view and then they go falling off, it'll take them 19.3 seconds to go splat. Sad face, right? Okay, that being said, it took that amount of time. To save yourself some trouble, this equation for time is equal to the total square root of 2d divided by g. All right, this is another one you can keep in your notes. Hope that helped. Feel free to use that. Have a great night.